Level 1 early ICBMs. The R-7 Semyorka was the Soviet Union's first operational ICBM. It used a two-stage design, meaning the missile had two separate rocket sections that fired in sequence. The first stage provided initial thrust to lift the missile out of the atmosphere, then separated. The second stage ignited to continue acceleration and deliver the payload to its target. The R-7 burned liquid fuel, specifically cryogenic propellants, extremely cold liquefied gases like liquid oxygen. These fuels provided high performance, but required the missile to be fueled immediately before launch, making it time-consuming to prepare. The R-7 could strike targets roughly 8,000 kilometers away and carried a single thermonuclear warhead. It launched from fixed surface pads, meaning the launch sites were permanent structures visible and vulnerable to attack. The SM-65 Atlas was the United States' answer to the R-7. It also used a two-stage liquid fuel design, but the fuel had to be loaded into the missile shortly before launch, a process that took time and exposed the weapon to detection. The Atlas achieved intercontinental range, meaning it could hit targets on other continents. It carried a single nuclear warhead enclosed in a blunt re-entry vehicle, a heat-shielded capsule designed to protect the warhead as it plunged back through the atmosphere at extreme speeds. The Titan II represented a significant improvement in readiness. It was a two-stage ICBM, but it used storable liquid fuel made from hypergolic propellants. Hypergolic means the fuel and oxidizer ignite on contact with each other, eliminating the need for an ignition system. More importantly, these propellants could sit inside the missile for extended periods without degrading, allowing the Titan II to remain fueled and ready to launch on short notice. The Titan II was housed in underground silos, vertical tubes built into the ground with reinforced concrete walls and heavy blast doors on top. This protected the missile from attack and concealed its location. The Titan II had intercontinental range and carried a single warhead with a very high explosive yield. The R-16 was the Soviet counterpart to the Titan II. It also used a two-stage design with storable hypergolic propellants, giving it similar fast readiness capabilities. The R-16 came in variants launched from both underground silos and surface pads. It had intercontinental range and carried a single heavy warhead. Level 2 MIRV adoption and heavy liquid ICBMs. The R-36M, also called the R-36M2 Voivode, received the NATO reporting name SS-18 Satan. This was a super-heavy ICBM built by the Soviet Union and designed specifically to maximize throw weight, the total mass of warheads and penetration aids the missile could deliver to intercontinental distances. It used a two-stage liquid fuel design and could reach targets approximately 16,000 kilometers away. The Satan could carry up to 10 MIRVs, meaning one missile could strike 10 separate cities or military installations. MIRV stands for Multiple Independently Targetable Reentry Vehicles. A MIRV system allows a single missile to carry multiple nuclear warheads, each of which can be aimed at a different target. This dramatically increased the destructive potential of each launch and complicated missile defense, because intercepting one missile no longer meant stopping one warhead. It could mean facing 10 separate warheads spread across hundreds of kilometers. The Satan launched from hardened underground silos, and after the Soviet Union dissolved, Russia continued operating it. The LGM-30G Minuteman III was the United States' primary land-based ICBM response. It used a three-stage solid fuel design. Solid fuel means the propellant is a stable, rubbery substance packed inside the rocket motor rather than a liquid stored in tanks. Solid fuel missiles can sit ready to launch for years without maintenance, providing constant readiness. The Minuteman III has a range of about 13,000 kilometers and is MIRV-Capable, meaning it can carry up to 3 warheads, though the exact number deployed on each missile has varied depending on arms control treaties and policy decisions. The missile launches from underground silos and remains on continuous alert, meaning crews are ready to fire within minutes of receiving an order. The DF-5B and DF-5C are Chinese heavy ICBMs based on the earlier DF-5 design. They use a two-stage liquid fuel configuration and are housed in underground silos. Their range falls in the 15,000-kilometer class, giving them true intercontinental reach. The upgraded B and C variants are MIRV-Capable, allowing them to carry multiple re-entry vehicles from a single booster. Level 3 Sea-Launched ICBMs, SLBMs. The Trident II, designated D5 and later upgraded to D5LE, is the primary SLBM of the United States and the United Kingdom. SLBM stands for Submarine-Launched Ballistic Missile, ICBMs fired from submarines rather than land-based silos or mobile launchers. These missiles are deployed on SSBNs, which stands for Ship Submersible Ballistic Nuclear, submarines designed specifically to carry and launch nuclear ballistic missiles. A submarine can hide deep underwater, constantly moving through vast ocean areas, making it nearly impossible for an enemy to locate and destroy before it launches. This makes SLBMs a critical part of what's called a second strike capability, the ability to retaliate even after suffering a massive first attack. The Trident II uses a three-stage solid fuel design which provides reliability and readiness underwater. The Trident II has intercontinental range exceeding 12,000 kilometers, meaning it can strike targets on any continent from international waters. It carries multiple independently targetable warheads, allowing one missile to hit several targets. The M51 is France's SLBM. It uses a three-stage solid fuel design and launches from Triomphant-class SSBNs. The M51 has intercontinental range and can carry multiple warheads, giving France an independent nuclear deterrent that does not rely on allies. The RS-56 Bulava is Russia's modern solid-fuel SLBM. It launches from Borei-class SSBNs and has intercontinental reach, placing it in the ICBM class despite being sea-launched. The Bulava carries multiple warheads and includes penetration aids, decoys and countermeasures designed to confuse missile defense systems and help the warheads reach their targets. The R-29 family includes the Sineva and Layner variants. Unlike most modern SLBMs, these use liquid fuel rather than solid fuel. They deploy on Russia's Delta-class SSBNs, which are older submarine designs still in service. The R-29 missiles have long-range and multi-warhead variants, maintaining Russia's sea-based deterrent alongside the newer Bulava. The JL-2 and JL-3 are China's submarine-launched ballistic missiles. The JL-2 uses solid fuel and deploys on Jin-class SSBNs. However, the JL-2 has limited range compared to other modern SLBMs, falling short of true intercontinental capability in some analyses. The JL-3 is a more advanced missile being developed for the next-generation Type 096 submarine. The JL-3 is designed to achieve full ICBM class range, extending China's sea-based nuclear reach. Level 4 Road, Rail and Mobile ICBMs. The RS-24 Yars is Russia's primary road-mobile ICBM, though it also exists in silo-based variants. Mobile ICBMs are launched from vehicles rather than fixed silos. This mobility makes them far harder to target in a preemptive strike because they can relocate constantly, forcing an adversary to search vast areas rather than simply aiming at known coordinates. Mobile ICBMs typically use solid fuel, which allows them to remain ready to launch without the delays and vulnerabilities associated with liquid fueling. The Yars uses solid fuel and has intercontinental range. The Yars carries multiple independently targetable warheads, giving each launcher the ability to strike several targets. The road-mobile versions deploy on TELs, which stands for Transporter Erector Launcher, large-wheeled vehicles that carry the missile horizontally during travel, then hydraulically raise it to vertical position for launch. Russia deploys the Yars on both mobile TELs and in fixed silos. The Topol-M, also designated SS-27, is another Russian solid-fuel ICBM that comes in both road-mobile and silo-based forms. It has intercontinental range and originally deployed with a single warhead. though modernization efforts have explored multiple warhead configurations. The DF-31 and DF-31A are Chinese road-mobile ICBMs. They use a three-stage, solid-fuel design and deploy on mobile launchers, allowing them to hide in China's road and tunnel networks. The range varies by variant, with the DF-31A reaching up to approximately 11,000 kilometers. These systems currently deploy with single warheads rather than MIRV configurations. The DF-41 is China's most advanced mobile ICBM. It uses a three-stage solid-fuel design and deploys on both road-mobile and rail-mobile platforms. Rail-mobile means the missile system can be transported and launched from specially designed railcars that travel on the regular railway network, disguising strategic weapons as ordinary train traffic. The DF-41 has an estimated range between 12,000 and 15,000 kilometers, giving it the ability to strike targets across the entire Northern Hemisphere. The DF-41 is MIRV-Capable, carrying multiple warheads on its mobile launchers. The Agni-VI is India's road-mobile ICBM. It uses a three-stage, solid-fuel design and has a reported range between 5,500 and 8,000 kilometers, though some estimates extend higher. The range classification places it at the threshold of intercontinental capability. The Agni-VI currently deploys with a single warhead and launches from road-mobile TELs. The Jericho III is Israel's road-mobile ICBM. It uses a three-stage solid-fuel design and has an estimated range between 4,800 and 6,500 kilometers, though some assessments suggest a maximum range up to 11,500 kilometers, depending on payload configuration. The missile has an estimated launch weight of 30,000 kilograms and a length of 15.5 meters. The Jericho III can carry a payload between 1,000 and 1,300 kilograms, which could include a single nuclear warhead or 2 to 3 low-yield MIRV warheads. It deploys on road-mobile transporter erector launchers and also has silo and railcar basing options. Israel maintains a policy of deliberate ambiguity regarding its nuclear capabilities and does not officially confirm the existence of nuclear-armed missiles. The Jericho III entered service around 2008 to 2011. The Shaheen III is Pakistan's road-mobile, medium-range ballistic missile. It uses a two-stage solid-fuel design and has a range of 2,750 kilometers, making it Pakistan's longest-range missile system. The Shaheen III launches from mobile transporter erector launchers, specifically using Chinese-manufactured 9-axle vehicles. It can carry both nuclear and conventional payloads. Pakistan designed the missile to reach targets throughout India, including the Andaman and Nicobar Islands in the Bay of Bengal. The missile was first tested in March 2015 and has been displayed in military parades. While the Shaheen III's range places it below the 5,500 kilometer threshold, typically required for intercontinental classification, it represents Pakistan's most capable long-range strike system. The RT-23, designated SS-24 Molodets by NATO, was a historic Soviet rail-mobile ICBM. It deployed aboard specially modified train cars disguised to look like ordinary refrigerated rail cars. The trains could travel throughout the Soviet railway system, making the missiles nearly impossible to track. The RT-23 had multi-warhead capability, carrying several MIRVs. The system was retired after the Cold War ended. The Bazarka-Barguzin was a planned Russian rail-mobile missile train project intended to revive the rail-mobile ICBM concept using modern solid-fuel missiles. Development began, but was later suspended due to budget constraints and strategic priority shifts. The Barguzin never became operational. Level 5, hypersonic capable and advanced ICBM carriers. The UR-100N, designated SS-19 by NATO, is a Russian two-stage liquid-fuel ICBM originally designed during the Soviet era. Russia has adapted this older missile to carry the Avangard hypersonic glide vehicle. Hypersonic weapons travel at speeds exceeding Mach 5, which is 5 times the speed of sound, or roughly 6,000 kilometers per hour. At these velocities, traditional missile defense systems struggle to intercept them because the weapons maneuver unpredictably and leave very little reaction time. A hypersonic glide vehicle releases from the missile's final stage while still outside the atmosphere, then glides back down at hypersonic speed while maneuvering to avoid defenses and complicate trajectory prediction. The UR-100N has intercontinental range near 10,000 kilometers and launches from underground silos. With the avant-garde payload, the missile delivers a maneuverable warhead that can change course during its descent, making interception extremely difficult. The RS-28 Sarmat is Russia's next-generation super-heavy ICBM designed to replace older heavy missiles like the SS-18 Satan. It uses a liquid-fuel, two-stage design and has an estimated range exceeding 18,000 kilometers, allowing it to strike targets anywhere on Earth, including by flying over the South Pole to avoid missile defense installations positioned along northern approach routes. The Sarmat is designed to carry many MIRVs or alternative payloads, including maneuverable warheads and hypersonic glide vehicles. It launches from hardened silos and has been publicly test-fired. Russia is in the process of limited initial deployment and testing. The DF-41 appears again at this level because it is also referenced in the context of carrying advanced reentry vehicles. Beyond its standard MIRV capability, the DF-41's solid-fuel mobile platform provides China with the option to deploy next-generation maneuverable warheads as they become available. Its long range and mobility make it a flexible platform for future payload advancements. The Agni-VI is a proposed next-generation Indian ICBM still in the developmental phase. It is expected to carry multiple re-entry vehicles, advancing beyond the single warhead Agni-VI. The Agni-VI would also feature extended range compared to earlier Agni missiles, potentially pushing India's reach deeper into true intercontinental territory. The missile remains in development and is not yet operational. Level 6. Super Heavy MIRV and Maximum Throw ICBMs. The R-36 M2 Voivode, specifically the SS-18 Mod 5 variant, also called Satan, is the Soviet Union and later Russia's Super Heavy ICBM. Super Heavy ICBMs represent the upper limit of throw weight capacity, the maximum mass of warheads, decoys, and penetration aids a missile can deliver to intercontinental distances. These missiles are designed to carry the largest possible MIRV loads or to deliver extremely heavy single warheads. Their size and power make them strategic centerpieces, capable of overwhelming missile defenses through sheer numbers of warheads or penetrating hardened targets with massive explosive yields. The Satan uses a two-stage liquid-fuel design and can carry up to 10 MIRVs. Each of these warheads can independently target a separate location, meaning one Satan missile can destroy 10 cities or military bases in a single launch. The missile has a range of approximately 16,000 kilometers and launches from deeply buried, reinforced silos designed to survive nearby nuclear strikes. The Soviet Union developed and deployed the SS-18, and Russia continued operating it after the Soviet collapse. The RS-28 Sarmat is Russia's super-heavy replacement for the SS-18. It uses a liquid-fuel design and is built to carry large MIRV loads or mixed payload packages. Mixed payloads could include a combination of traditional warheads, hypersonic glide vehicles, and decoys to saturate and confuse enemy defenses. The Sarmat has an estimated range exceeding 18,000 kilometers, allowing it to reach any point on the planet via multiple flight paths, including trajectories over the Arctic or Antarctic. It launches from silos and has been test-fired publicly. Russia is beginning limited deployment. The DF-5C is a Chinese heavy ICBM in the DF-5 family. It uses a silo-based liquid-fuel design and represents the MIRV-capable variants of this long-serving missile line. The DF-5C has intercontinental range around 15,000 kilometers and can carry multiple independently targetable warheads. China operates the DF-5C as part of its silo-based deterrent force. The LGM-118A Peacekeeper, also known as the MX, was a United States solid-fuel, silo-based ICBM deployed during the late Cold War. It carried 10 MIRVs and was designed for high accuracy, allowing it to strike hardened military targets like enemy missile silos. The Peacekeeper represented the peak of American throw weight and MIRV capacity. However, after the Cold War ended and arms control treaties reduced nuclear arsenals, the United States retired the Peacekeeper. The RS-56 Bulava appears again at this level because despite being a submarine-launched missile, it has MIRV capability and ICBM class range, placing it among systems with significant throw weight for multiple warheads. The Bulava uses solid fuel and launches from Russian Borei-class SSBMs. Its ability to carry multiple warheads while remaining mobile at sea gives Russia a survivable high-capacity nuclear deterrent. The Ababeel is Pakistan's first MIRV-capable medium-range ballistic missile. It uses a 3-stage, solid-fuel design and was unveiled in a test conducted in January 2017. The missile is reportedly capable of carrying multiple independently targetable reentry vehicles, allowing a single missile to strike several separate targets. This capability makes the Ababeel harder to defend against compared to single-warhead systems. While the Ababeel's range places it below Intercontinental classification, its MIRV technology represents a significant advancement in Pakistan's strategic capabilities. The missile's development likely began during the mid to late 2000s, and its design shares characteristics with other missiles in Pakistan's arsenal. Level 7 Regional and Emerging State ICBMs. The Hwasong 15 is a North Korean large 2-stage liquid fuel ICBM that uses liquid fuel. It launches from mobile TELs, giving it some degree of survivability through relocation. North Korea claims the Hwasong 15 has a range around 13,000 kilometers, which, if accurate, would allow it to strike targets across the continental United States. The missile has been displayed in military parades and tested in launches that North Korea publicly documented. However, the actual range and payload capacity remains subject to external dispute because independent verification is limited. Analysts debate whether the Hwasong 15 can carry a functional nuclear warhead to its maximum claimed range, as increasing payload mass reduces achievable distance. The Hwasong 17 is a larger liquid-fuel ICBM that North Korea claims exceeds 15,000 kilometers in range and can support multiple warheads. Like the Hwasong 15, it deploys on mobile launchers, which North Korea has demonstrated in tests and propaganda releases. The Hwasong 17 represents North Korea's effort to field a more capable ICBM with greater throw weight and potentially MIRV capability. However, its actual operational capability, reliability, and the accuracy of North Korean claims remain contested internationally. Intelligence agencies and independent analysts continue to assess whether the system can perform as advertised under combat conditions, particularly regarding re-entry vehicle survivability and guidance accuracy. The Hwasong 18 is North Korea's first solid-fuel ICBM and represents a major technological advancement. It uses a 3-stage solid-fuel design and launches from a 9-axle transporter erector launcher using cold launch technology. Cold launch means the missile is ejected from its canister before the first stage motor ignites, protecting the launcher from exhaust damage. The Hwasong 18 is estimated to be 25 meters long, 2.1 meters wide, and has a body mass of approximately 55 to 60 tons. The use of solid fuel makes the launch more difficult to preempt than previous liquid-fueled missiles because it does not require hours of fueling and needs fewer support vehicles, making it easier to conceal. The missile was first unveiled in February 2023 and successfully tested 3 times during 2023 in April, July, and December. North Korea characterized the December launch as a launching drill of an ICBM unit, indicating the system is now operationally deployed. When tested on highly lofted trajectories reaching altitudes over 6,000 kilometers, analysts estimate the Hwasong 18 could potentially fly as far as 15,000 kilometers on a standard trajectory, enough to reach anywhere in the continental United States depending on payload weight. The Hwasong 19 is an evolution of the Hwasong 18 with increased size and capability. It uses a 3-stage solid fuel design and launches from an 11-axle transporter erector launcher, larger than the Hwasong 18's 9-axle system. The missile is estimated to be at least 28 meters long, making it longer than the Hwasong 18 and longer than Russia's mobile ICBMs. The Hwasong 19 was first tested on October 31, 2024, in a highly publicized launch supervised by North Korean leader Kim Jong-un. North Korean state media claimed the missile as the world's strongest missile and described it as perfected. The missile uses a new solid fuel engine made with composite carbon fiber material that produces 1,960 kilonewtons of thrust. However, the missile's large size could limit its deployment area and mobility, making it more vulnerable to detection by intelligence agencies before launch and making it a potential priority target for preemptive strikes. North Korea plans to use the Hwasong 19 alongside the Hwasong 18 as its primary core means of defense, and it may be intended to replace the older liquid-fueled Hwasong 17. To see how the entire chain of command fits together, check out our breakdown. Every rank in the US Army explained in detail.